Okay, today we're going to talk about section 5.4, which is systems of nonlinear equations. So a system of a nonlinear equation basically just means that you're going to have two or more equations which are not lines. So let's kind of recap what it was real quick. If we had two linear equations, remember the idea was if I had two linear equations, we had a few different possibilities. But the most common possibility was that if I had a line, and then I had some other line that was drawn on here, and those two things cross someplace, that crossing right here, that was the solution. It's where they intersected. That's the solution of the system of linear equations. Well, now what we're going to have is a possibility of nonlinear equations, which means it could be any kind of a figure. Specifically, we could be using a parabola. Maybe we have a parabola which looks something like this. And maybe it's another parabola that that intersects it, or maybe it's something else. Maybe it's a circle. So you've got systems of two nonlinear equations. What the difference is that you should see here is that I have more than one intersection. As a matter of fact, this thing crosses twice. And one of the biggest things here is going to be recognizing when you see certain equations, what those equations look like, so you have somewhat of an idea of how many possible solutions there could be. For example, real quick here, with the idea of a parabola and a circle like the one I just drew, we have a few different possibilities. We have the possibility, here, let me go ahead and scroll this up here. We have the possibility of exactly what we had, where we have two intersection points. However, it's also possible that we have a parabola, does something like that, and the circle does something like this, where maybe the parabola and the circle only intersect at one point because the parabola happens to hit only the very outside of the circle somewhere, or it's tangent to the circle at one specific point. So it could intersect through 2 points, it could intersect at one point, and then of course it's also possible, I'm not going to draw this one, but it's also possible that these two things don't intersect at all. Maybe that parabola is up higher than the circle and they never touch. So we have those different possibilities. With things like circles, we could have multiple possibilities there. You could have 2, you could have 1, you could have 0. So there's different possibilities here of different numbers of intersections. So we're going to have to take that into account when we start going through our examples. Okay, so our first example, we're going to solve a system of nonlinear equations by substitution. Fortunately, the methods that we're going to use are very similar to when we did systems of equations. We're going to use the substitution method on a couple of these, and we're also going to be able to use the elimination method by addition. And we did both of those when we solved systems of linear equations. Now, these examples can take a little bit longer, so we're not going to do as many. I think we're only going to do about 4 examples, 2 for substitution, 2 for elimination, but that should be enough to be able to give you the general idea. All right, so our first example, excuse me, we're going to have the system of x squared equals 2y plus 10, and the other equation is going to be 3x minus y equals 9. So what you should recognize, and hopefully we'll start to really see this as we go through more of these, the top equation, because the x part is squared and the y part is not squared, this one is a parabola. That one's a parabola. It's a quadratic equation. So it's going to have the general U shape. It's either going to open up or down depending on which way it is. The second one, well, there's no squares on either one of the variables, so that's linear. It's going to be a line. So what I have is a line intersecting with a parabola, or possibly intersecting with a parabola. So again, if you think about it, a line could intersect a parabola 2 times, because it could cross through twice. It could touch just the outside of the parabola, or it might not touch it at all. So let's figure this out. Let's go ahead and figure out whether we have 1, 2, or 0 solutions to this thing and what those solutions would be. Well, in order to do that, it says we're going to use the substitution method here. And the reason it's easy to use the substitution method, just like before, is that one of my variables here on one of these equations has a coefficient of a 1 out front. And if you look, the y here has a coefficient, technically it's a negative 1 out front, but we can make it a positive 1 by adding or subtracting that y appropriately to the correct side. So what I want to do here is I want to rewrite this bottom equation. I want to add the 9 to both sides. So that's going to give us, from this bottom equation, we'll bring it over here, it's going to give us 3x. And if I add 9 to both sides, I get 9 plus y. But I want to solve it for y, so that means I have to subtract the 9 on both sides. So we would get that 3x minus 9 equals y. And what that allows me to do now, it allows me to take everything here, which is y, because that's what it says, it's equivalent to y, and I'm going to take that stuff and I'm going to plug it all in right there for that y. And then I have that top equation in nothing but x's. So let's go ahead and do that and see what we get. So we're going to have x squared equals 2 times, now I'm going to substitute the 3x minus 9 in where the y was, and then we'll add 10. Alright, to solve this, let's distribute the 2. Let's get rid of those parentheses. So we'll have x squared equals 6x minus 18 plus 10. We'll combine our like terms on the right side, and that's just the negative 18, then a 10. So we get 6x, and then negative 18 and 10 is negative 8. Now what I have is I have a quadratic in one variable. In order to solve this, we need to get everything to one side or the other, so we can set one side equal to 0. So we're going to subtract the 6x and add the 8. We'll subtract the 6x and add the 8 from both sides. Subtract 6x and add the 8. And then let's see what we get here. So on the left side now we've got x squared minus 6x plus 8. And then on the right side we get 0. So this then becomes a factoring problem. We're going to have to solve this for the values of x. So if I factor this, the first parts have to be x. The factors of 8 that are going to add up to negative 6 are going to be minus 4 and minus 2. So that means if I split these things up, set them each equal to 0, I get that x equals 4 or x equals 2. I hope that that part right there was intuitive. So what that tells me is that I have 2 possible solutions. Remember, this is only half of the solutions. I need to find the y values. Well, I can go back, and in this case, it's probably going to be easier to take these values and use this this equation right here because it's already solved for y. Assuming we didn't make any mistakes in our manipulations, and we didn't in this case, we're going to be able to use that equation. So when x equals 4, I need to plug the 4 back into this equation to get the y value. So we're going to get 3 times 4 minus 9. Well, 3 times 4 minus 9 is 12 minus 9, which is 3. So what that tells me is my first point of intersection is the point 4, 3. And then we need to take and plug in our second point, which was x equals 2. Again, back into that same equation. So 3 times 2 minus 9 is our y value. 3 times 2 is 6. Minus 9 is negative 3. So what that tells me is that our second point of intersection is the point 2, negative 3. So we should have 2 points of intersection on this graph. The points 4, 3 and the point 2, negative 3. So this line crosses that parabola 2 times. Okay, for our second example, it's going to be a little bit more involved algebraically. We're going to have x minus y equals 3. And then we're going to have the equation x minus 2 squared plus y plus 3 squared equals 4. And again, it really does help if you can kind of look at these and recognize what they are, so you have an idea what you're looking at for possibilities. The top one is x minus y equals 3. Both variables are only raised to the first power, so we know that that's a linear. That's just a line. The bottom equation, hopefully you recognize that form. That form is the form of a circle. The circle with a center of 2, -3, and a radius of 2. But ultimately, the idea is that is a circle. So a line can intersect a circle. It could go right through the circle and actually intersect it twice. It could just touch the outside of the circle, maybe at one point somewhere, and intersect it once, or it could completely miss the circle and there would be no solution to this at all. So let's go ahead and figure this one out. Once again, we're going to use substitution. The reason we're going to use substitution is because in this case, the top equation, both x and y have coefficients of 1. In this case, the x actually has a coefficient of 1, while the y has a coefficient of -1. So it's easier just to use the x here. So we're going to manipulate the top equation by adding y to both sides. So we would get that x equals y plus 3. And then what we're going to do is we're going to take that y plus 3 and we're going to substitute that into the x right here. And then all we're going to have left is everything in terms of y. So let's go ahead and do that. Let's go ahead and substitute y plus 3 in where the x was. Subtract 2. Don't forget the squared. And then we've got y plus 3 squared equals 4. Okay, so now in the first equation, we're going to simplify the inside of the parentheses. It's y plus 3 minus 2. Well, y plus, and then 3 minus 2 is just 1, so we get y plus 1 squared plus y plus 3 squared equals 4. Now, in order to finish this, we're going to have to FOIL both of these parentheses out and then do a bunch of combining. Like I said, it's going to be a little bit longer algebraically. So if we FOIL the first one, remember that that is y plus 1 times y plus 1. Okay, I'm not going to write that out, but when you FOIL it, you would get y squared plus 2y plus 1. And in the second one, you would get y squared plus 6y plus 9. And then that equals 4. So now we have to combine all of our like terms, and then we have to solve what would be, again, another quadratic equation. So I've got a y squared and a y squared. That's going to give us 2 of them. So I have 2y squared. I've got 2y and 6y, which will be 8y. And then I've got 1 plus 9, which is 10. So now I have to get everything to one side, so I'm going to subtract the 4 from both sides to make the right side equal to 0. So we'll have 2y squared plus 8y plus 6 equals 0 after I subtracted 4. Now the one thing that I see here is that I have a 2 in common. I can factor this 2. As a matter of fact, I can divide the 2 out of both sides of the equation. And if I divide every single term by 2, which includes the 0, you also have to divide the right side, but 0 divided by 2 is still 0. If we divide everything by 2, we're going to get y squared plus 4y plus 3 equals 0. Was this step absolutely necessary? No, but it does make things easier for us to factor. Instead of having a 2 out in front of that y squared and a whole bunch of big numbers, this should be much easier now to factor. So this has to be a y and a y. The factors of 3 that are going to add up to 4 are simply 3 and 1. So that means here that y would have to equal -3, and y here would have to equal -1. So once again, it looks like we're going to have 2 solutions to this. So we have to test our solutions to get our x values. So y equals -3. I think I'm going to use this, because again, it's already solved for x. So all I have to do is plug the y value in, and we'll get out an x value. So let's go ahead and plug it in. X here is going to equal -3 plus 3, substituting the -3 in for y. Well, that just means that x is 0. So when y is -3, x is 0. So our ordered pair, our solution, is the point 0, -3. Remember, it's always x first, then y. So there's our first solution. Okay, we need our second solution. And that one's going to be when y equals -1. So again, we plug in the -1 where the y was, and we get out here that x is -1 plus 3, which is 2. So our second solution is 2, -1. So what that tells me is that our line intersects the circle at two different points, and those points are the points 0, -3, and 2, -1.